Hi, previously we did two examples of the curtailments of the reinforcement bar in continuous beam under two different situations. Now let us try another example under another type of the situations which involve the other considerations. This time, you will have the members to be more heavily reinforced and the beam span is relatively short. At the end of the day, the parameters governing the final layout of the reinforcement, it will be slightly different than the two examples previously. Without further ado, let us look into the example. Given the simplified rules for the curtailments, your beam cross sections is 200 times 750 mm. Your concrete cover is 30 mm. The aggregate size 20 and the link size at mm. The span is shorter, 3.5 meter, but it is heavily reinforced. You have a lot of reinforcement bar here. You have 5T16 as a top reinforcement bar and 4T16 as the bottom reinforcement bar. At the current stage, you don't know how will be the layout of the reinforcement. The final layout of the reinforcement, it will be governed by whether the spacing is sufficient, meeting the requirements of the minimum spacing. In order to maximize the performance with the best arrangements of the reinforcement, you will have 4T16 arranged together in order to get the maximum effective depth as possible. Of course, you can have 5 reinforcement bar laying at the same level. But due to the relatively small width of the beam, that is not likely the case. The second options for you, it will be having the 5 reinforcement bar arranged in this manner. Again, we're going to start with checking the minimum bar spacing. Since both the bottom and the top reinforcement bar are the same size, the minimum bar spacing as governed by the bar size, it will be 16. Governed by the aggregate, it will be aggregate size plus 5 mm, which is 25. And also governed by the minimum width of 20 mm. The biggest value of the three governs, that means it will be equals to 25 mm. Then you're going to check the spacing between the reinforcement. For the top reinforcement here, get the width minus the cover from both sides, which is 35 mm times 2, minus the shear length from the both sides, which is 8 mm times 2, minus 3 rebar times 16 mm diameter. The whole thing here is divided by 2 due to the spacing. Your actual spacing is 33 mm. This is slightly bigger than the minimum requirement. That means the actual spacing is sufficient. Therefore, you can keep the arrangements of the reinforcement bar something like this. Next, you would like to test these arrangements of the reinforcement. Take the width minus 2 cover minus 2 link size minus 4 units of 16 mm rebar. There are 3 spacing in between. That means this whole thing here is divided by 3. Your spacing available between the rebar is 16.7 mm. This is not sufficient. Therefore, you cannot have the reinforcement bar arranged in this manner. Instead, you can stack the reinforcement to be something like this. You will do the calculations for the actual spacing. Get the width minus the cover, both sides, minus the rebar, both sides, minus 2 rebar. You will get the spacing between rebar at 2 mm. This is greater than the minimum spacing. With that, Your final arrangements of the rebar at the midspan and at the support, it will be something like this. Our next step here is to do the curtailment. You may do the curtailment based on the minimum percentage given here and the locations indicated here. Let us do the simple one first, which is the bottom reinforcement. For T16, if you need to cut the reinforcement, you need to have a minimum of 2 rebars, one at each corner of the shearing. That means you can cut the 2 reinforcements which are staggered on top of the reinforcement. Initially, you have 4 T16 arranged in this manner. Then you curtail the top rebar here. That gives you 2 T16 near to the support. You need to keep at least 2 bar here, one at each corner. So that would be the arrangement here. By reducing from 4 units to 2 units here, the provided amount of reinforcement bar is 50%, which is greater than the minimum of 30%. This is acceptable. Next, you need to determine the locations where you do the curtailment. Based on the effective span of 3.5 meter, this side it will be 10% of the effective span, which is 350 mm. The other side, it will be 0.15 times the effective length, which is 525 mm. These numbers are rounded to the nearest 25 mm. 1 inch equals to 25 mm. This allows easy conversions from SI unit to imperial units. With that, we have the bottom reinforcement bar settled. Next, we'll deal with the top reinforcement. Initially, at the interior support, we have 5 units of T16 bar. You can start reducing the amount of reinforcement bar here into 3 T16. That gives you 60% as compared to the 5 units of T16. 60% is just nice as indicated here. Then you may stick with 3 T16 here. And then you can curtail the reinforcement bar and reduce it more towards the end support here. Here 5T16. Here you will have 3T16. And you do the curtailments of the middle bar here that give you 2T16s near to the support. Calculating the percentage of the reinforcement, it is 40%, which is greater than the 20%. Then you see a progressive reductions of the amount of reinforcement towards the end support. Next, you will need to determine the locations. This curtailments of that 2 reinforcement bar here, converting 5 units to 3 units, is governed by 0.15 times the effective length, which is equals to 525 mm. And for where the 3T16 end, it is governed by 0.25 L. Get 0.25 times the effective length of 3.5 meter, you get at 75 mm. Based on the requirements here, both this length will have to be at least greater than 45 times the bar diameter. 45 times the bar diameter here is equals to 720 mm. This 720 mm is slightly bigger than this one, but lesser than this. Therefore, you can stick with this at 75 mm. But this one, you cannot put it 525 mm. You're going to use a bigger one, which is 720 mm. That means you're talking about this bar here, it will be slightly extended as compared to this 2 bar. And then being cut at these locations, which is at 75 mm, until it give you the layout of the reinforcement bar here. Now, if you observe the dimension here, it is not being rounded to the nearest 25 mm. In order for you to round up to the nearest 25 mm, you will need to round it up to 725 instead of rounding down to 700 mm. Why is it so? If you round it down to 700 mm only, that means there will be a stretch not fulfilling this 100% amount of reinforcement. And the distance here is calculated on the basis of the surface of the internal support. Once you have done all this, to finalize the detailings of the reinforcement, it should look something like this. If you cut the section here, you will have 5T16 on the top and 2T16 at the bottom. If you cut the section here, you have 3T16 at the top and 4T16 at the bottom. Now, if you cut the section here, 2T16 on top and 4T16 at the bottom. And lastly, if you cut the section here, you have 2T16 and 2T16 at the top and at the bottom. The locations where you have your reinforcement bar curtails are indicated here. Now, if you observe in terms of the dimensions, especially when you encounter the case deciding whether you need to round it up or to round it down, the top bar you will have to round it up so that you will have more bar provided extending from where it should be curtailed. However, for the bottom bar here, this distance you will need to round it down so that the bottom bar here can extend further in order to fulfill that 100% amount of reinforcement bar at these specific regions. Now, if you have difficulty to imagine whether to round up or to round down, you just need to follow a basic principles. We want the reinforcement bar to be more, but not less. Then you can compare the two options. Whether rounding up will give you more rebar or whether rounding down will give you more rebar. If you round up the distance for the top reinforcement bar here, it will give you more reinforcement. That means the top reinforcement bar, you have to round it up. Now, if you round it down, the reinforcement bar will give you more areas. Then the bottom bar here, this distance will have to be rounded down. That is the basic principles. As you can see here, the final layout of the reinforcement bar very often does not comply fully with the percentage of the reinforcement bar as indicated here. And because of the conversion issues between the SI units to imperial units, sometimes we need to do some rounding up and rounding down. That means sometimes it doesn't fully comply with the exact locations where you can do the curtailment. Then you need to be wise when you choose the amount of reinforcement bar to be curtailed, as well as the locations of the reinforcement bar to be curtailed. And lastly, present the outcome of the layout of the reinforcement bar in the detailings. And these are the detailings that you need to present to the contractors for them to know how they're going to lay their reinforcement. And you're going to see something like this in the standard drawings of the reinforced concrete structures.